Hello and welcome to another 3D printing video. This video's topic is 3D printing technologies, power bed fusion, DMLS. So DMLS, what does it stand for? It stands for direct metal laser sintering. Well, you could say that the working principle is exactly the same as with SLS machines. So there's a laser, just like in SLS technology, and the laser melts the metal powder. Obviously, the laser needs to be very, very higher powered compared to the SLS machine, but otherwise the printer works basically the same. So the laser moves in the X and Y direction, melts the plastic, and once it has melted the plastic for that layer, there's a roller which sweeps over and pushes the new powder in. But what are the differences then again compared to SLS methods? Well, a DMLS printer has much more powerful laser, and the chamber itself heats up more because it needs to be heated up to close to the point where the powder melts, but not to that point yet. The laser itself pushes the powder up over the melting point. So laser does the final push. And with this technology, you need to replace all the oxygen inside the printing chamber, and it needs to be replaced with an inert gas. So the printing is possible, and this gas also helps so the powder will be still usable later on. And one another difference compared to SLS is that you can't print in so-called 3D directions with this technology. You need to have supports with DMLS technology because of the heat expansion of the parts. You need to have more supports. You need to have supports for the part itself, and you need to have supports for the heat expansion too. And what materials you can print with this technology? It's like steel, titanium, aluminum, tool steel, and more are being developed every day. Copper, I think, was the latest addition to this technology. So what about the printers in this sector, the industrial equipment? Well, there's SLM 280 production series machine, which costs around 250,000 euros. And then there's another example, EOS M290, which costs again over 250,000 euros, but still under 5. No, I think it's from 250 to 1 million. The price tag for both. And the build volume for these machines is like almost 30 centimeters by 30 centimeters by 35 centimeters. What about the so-called consumer printers? Again, these are with parentheses because the prices for these machines are quite high. So there's this machine called one-click metal imprint, which costs around 55,000. You can print aluminum with it and titanium with it, but the build volume is quite small, so it's 15 centimeters by 15 centimeters by 15 centimeters. And then there's the Sherbot metal one, which costs around 90,000 euros, and the build volume is even smaller, around 65 millimeters by 65 millimeters by 100 millimeters. So the consumer printers aren't that big. You can't print that big prints with these machines. Basically, hand-sized prints. It's a good measure for these machines. But what about the applications? So where can you use it? You can use it pretty much anything you require metal parts in. You can use this technology to replace machine parts. For example, on the left, there's a hydraulic valve block, which is 66% lighter and smaller than the previous one. All around, it was more optimized than the previous one, which was traditionally machined. And it became almost service-free after it was 3D printed, because it consisted only from one block, so to say. And on the right-hand side is another similar case. It was a product that was manufactured with traditional methods. it was assembled from over 30 different parts, but it was very much bulkier and more heavier than its 3D printed counterpart. It weighed around 2.9 kilograms, and it really did have 33 components. And then on the left hand side, from that part, is the 3D printed counterpart, which is just one piece, and it weighs 175 grams. So there's a really huge difference on optimization on this part, and it still withstands the same value of requirement for the part than with the traditionally manufactured part. So then there's the medical. Here's a good example on the medical side with metal prints used in hip and pelvic surgeries. These implants are more efficient than the ones made with conventional methods, and they are also cheaper to produce, and you can make these really according to your customer or the patient, so they are unique. You can make them unique. Then there's the car industry, for example. On the right hand side, there's Bugatti trying out 3D printed brake calipers, and on the left hand side, there's Mercedes-Benz 3D printing spare metal parts for its truck and some more older models that they tried out in 2017. So each and every car manufacturer is trying out printing parts for their cars. Of course, these were just a few examples for the areas where you could use metal prints. Obviously, you can use them wherever you just think of using them, so to say. And what are the pros and the cons on this technology? Well, the pros is, again, so-called material recyclability. So you can recycle the powder, excess powder. And parts are durable, obviously, because it's made out of metal. And there's not much post-processing. You just need to clean out the supports, and then you're good to go. And ever-growing material library, so they are coming up with new materials at least 1.5 a year. What about the cons? Well, full clean again. Same with the SLS machine, full clean again after each print and material change. So you don't have that excess powder in the places you don't need them. So the machine will be usable for a longer time. And this technology requires inert gas used in the chamber and requires their own space because of the metal tiny powder, and the machines are huge. And it's very expensive, and for the consumer side, it still has really small build volume. So it's a great replacement for machining, CNC machining, and you can still create shapes that you cannot create with CNC machining so easily. But yeah, this was the end for this video. Hope to see you in the next one.